Today we're looking specifically at the graphs of exponential growth and decay functions, and I put the graphs in here for you so that we can hopefully see some of what's happening without having to take the time to graph all of them ourselves. So the parent function, the original function, is y equals 2 to the x, and that's graphed here on the left. What I want you to notice is that it has this point at 0, 1. If we put a -4 in the exponent, that point moves to 4, 1. So instead of being here at 0, 1, that point has moved right 4. So this -4 means that the whole graph shifted right 4. This shouldn't be too surprising because every single function that we have looked at so far, any number with the x is opposite of what you would expect, and it moves the graph left or right. So left is plus, minus is right. And so notice in example B, instead of that point being at 0, 1, it's now at -3, 1, because the +3 moved this graph left 3. So how did A change from the parent function? It moved right 4. And how did B change? It moved left 3. So what role does that H play? Plus H moves left, minus H moves right. Any number added or subtracted with the x moves the graph left or right, and it's crazy town backwards of what you would expect. So plus moves left, minus moves right. Okay, a couple other features of this graph. This is a curved graph, but do you notice how in the parent function, the graph appears to get closer and closer to the x-axis? It looks like it's touching the x-axis, but it's actually getting super, super close and not crossing. So it's never going to cross that x-axis. So this original graph is 1/2 to the x, and again it goes to the point 0, 1. In this point, or in this graph, the point, instead of being at 0, 1, it is now at 0, 4. So it has moved up 1, 2, 3 units. This +3 means up 3. This -5 is taking the original point, which was here, 1, 2, 3, 4, 5 units down. So D has been moved down 5. So the plus or minus after the exponent term moves that graph up or down. It's honestly easier to look at what's called the asymptote. We're going to talk about the asymptote in a minute. But this graph gets closer and closer to the x-axis. That's the asymptote. Here, that asymptote is at 3 because the graph has been moved up 3. And on D, the asymptote is down at -5 because the graph has been moved down 5. So that plus k moves the graph up, minus k moves the graph down. Okay, this next part is showing a number in front of. So if we start with y equals 2 to the x, if we make it 3 times 2 to the x, notice that 3 becomes the y-intercept. So instead of, like, how am I going to explain this? This one is really 1 times 2 to the x, and it crosses the y-axis at 1. This one is 3 times 2 to the x, and it crosses the x-axis at 3. That is called a stretch. The next one is 1/2 times 2 to the x. It crosses the x-axis, or the y-axis, at 1/2. That is a vertical shrink. And, oh, looks like I didn't get this formatted very well when I redid the notes. This one is y equals -2 times 2 to the x. The negative is going to flip the graph over the x-axis, and that -2 tells us where it crosses the y-axis. So this a value is going to stretch if it's bigger than 1, shrink the graph if it's something like 1/2 or a fraction that's smaller than 1, and a negative there will flip the graph. The asymptote is the line that the graph approaches as you move away from the origin. Basically, exponential growth and decay graphs have an asymptote that originally is the x-axis. The graph is going to approach that asymptote but never cross it and never really touch it. So if we look at this basic equation, y equals a times 2 raised to the x, that a is going to tell us where it's going to cross the y-axis. So the y-intercept is that a value. So if I ask you, what is the y-intercept of 5 times 2 to the x? The y-intercept would be 5. It would cross the y-axis at 5. It would have the point 0.05 on it. The x-axis is an asymptote. It's a crazy word that has way too many consonants in it, but that's the word. The x-axis is an asymptote of the graph. That means that this graph is really, really close to the x-axis. It gets closer and closer, and if you were to zoom in and zoom in and zoom in, it would constantly be getting closer to the x-axis, but it's never really going to get to 0, and it's never going to cross that asymptote. The domain is the super easy part. The domain is all real numbers. And the range is either y is greater than 0 or y is less than 0. It is y is greater than 0 when the graph points upward. So let's see, I'm going to point a little picture. This graph has a range of y is greater than 0 because it's above the x-axis. This graph would look more like this. It has a range of y is less than 0 because it's been flipped upside down and it's underneath the x-axis. So we've done examples like this. We've done homework problems like this before where I'm going to give you the equation and you're going to explain how this graph has moved, where is the asymptote, what is the domain, what is the range, just from the equation. So we don't actually have to look at the graph, we're just going to look at the equation. So remember, the a value is going to control stretches if it's greater than 1, or a shrink if it's like a fraction or a decimal less than 1. And if this is negative, it will flip the graph over the x-axis. The -h, that controls horizontal movement. Minus will move the graph to the right. Plus will move the graph to the left. And the plus k moves the graph up or down. Plus moves the graph up, and minus moves the graph down. Okay, take a moment, pause the video, get out your worksheet for today. It's worksheet 4. So pause the video, get out worksheet 4, and then play the video again. So here's your worksheet, and I was trying to think of which of these we should do together. Let's do number 14 together. So number 14, it's asking, is there any horizontal movement? Is this graph going to move left or right, and how much? And because it says -5 in the exponent, yes, this is going to move right 5. So this minus 5 tells us that we are going to move right 5. The plus 4 is going to be the vertical movement. That moves the graph up 4. Now, here's what I want to make sure that you notice. The vertical movement is going to change where the asymptote is. The parent function has an asymptote at y equals 0, at the x-axis. The vertical movement is going to be linked to your asymptote. So because this graph moved up 4, the asymptote is now going to be the horizontal line, y equals 4. So originally, the original asymptote, I'm just going to write this at the bottom of the paper, the original asymptote is y equals 0. If the graph moves up 4, the new asymptote is at y equals 4. If the graph moves down, the asymptote is going to be y equals negative however many units down this moved. So you may want to look at all these problems and just go ahead and write in the asymptote based on how this moved up or down. Okay, this one does have a stretch or a shrink. That would be this number in front. This one is going to be a shrink. If it doesn't have one, like look at number 13 doesn't have one, you just write none. Number 13 also doesn't have any vertical, so you'd write none. If there's none, you just write none. For direction, I want you to write flip or no flip. This is a positive 1/2, so it is going to be no flip. The domain is all real numbers. You could basically write that in for all of the domains right now because all of the domains are all real numbers. The range, if there's a flip, the range would be y is less than. If there is not a flip, the range is y is greater than, and it's going to be greater than or less than the asymptote. So if there is a flip, then the range is going to be y is less than the asymptote. If there is no flip, the range is going to be y is greater than the asymptote. So the vertical movement, the asymptote, and the range are all very connected. And the range is a little bit connected to the direction as well because the direction, whether there's a flip or not, tells you if it's a greater than or a less than symbol when you're doing the range. So I want you to try this worksheet on your own. Finish those other 5 problems, work together, and we will check that on Tuesday.